Hello students, welcome to the second lecture on the lecture series on area perimeter of basic geometric figures. So in the previous lecture, we learned some of the basic formula for area and perimeter of square, rectangle and some triangles. Okay, so in this lecture what we'll do is we'll continue to do so and complete all the theory sections of this chapter. Okay, so let's go forward and do all the remaining parts. So we'll be covering concepts and theory. Okay, all the remaining parts. So what we learned in the previous lecture, we learned triangle angle sum theorem. So what it told us that the sum of interior angles of a triangle is always 180 degrees. Okay, so if this is alpha, this is beta and this is gamma, then alpha plus beta plus gamma will actually be equal to 180 degree. Okay, so basically if you are given alpha beta, let's say alpha is equal to 60 and beta is equal to 90. Okay, then what gamma will be equal to? So we can use this formula to evaluate. So alpha is what, 60 and beta is what, 90 and gamma is unknown right here. So it will be equal to 180, right, using the triangle angle sum theorem. So this implies that what we can do is we can subtract actually 120 from both the sides. So what will be left in the left side is gamma and in the right side it will be 180 minus 120. So it will be actually equal to 60 degree. Okay, so gamma will actually be 60 degree. It won't be actually 60. Okay, it will be 60, it will be 150, right? So it will be 30 degree. So let's go forward and see the next theorem that we learned in the previous lecture. So the sum of length of any two sides of a triangle is actually greater than the length of the third side. This is called the triangle inequality theorem. So if this side is denoted by z, this side length is denoted by x, this side length is denoted by y, then what will imply? So z is actually less than x plus y and x is actually less than z plus y and y is actually less than z plus x. This is what it will denote, that is the triangle inequality theorem. Okay, so let's try to see the categorization of triangles in terms of angles, angle as the parameter. Okay, so we also learned that what is acute triangle. Acute triangle is a triangle where all the angles are actually less than 90 degree. Okay, so you can see an example right here where all the angles of the interior angles of the triangle are actually less than 90 degree. So what is right angle triangle? So where one angle is exactly 90 degrees. Okay, so you can see the example right here where one angle is actually 90 degrees, right? So let's see option number 3, that is obtuse triangle. So that is one angle is actually greater than 90 degree. Okay, so this is the obtuse triangle where one angle is actually greater than 90 degree. Okay, so this is called obtuse angle triangle. This is called right angle triangle and this is called acute angle triangle. Okay, so let's see types of triangles by sides and angles. Okay, so right isosceles triangle, a right triangle with two legs of equal length. Okay, so right isosceles, we all already know what is isosceles triangle. Okay, a triangle where two sides are of equal length. Okay, and their adjacent angles will be actually equal to. Okay, that is a property that it possesses. So here what is right isosceles triangle? So one angle must be right angle triangle. So you can see right here one angle is actually 90 degree angle. Okay, and isosceles triangle, so two sides must be equal. So these two sides must be equal, and so since this is 90 degree, so and these two, so let these two angles be what, x. So x plus 90 is equal to 180. Okay, because all the sum of the interior angles is actually equal to 180 degree. So this implies that 2x is equal to 90. So this implies that x is equal to 45. Okay, that is how we knew that these two angles will actually be 45 degree of value. Okay, or measure. Okay, so we already know that in a what, right angle triangle. Okay, so in a right angle triangle, how we can actually evaluate the diagonal? Basically, if we see the square, okay, we learned that how we can actually evaluate the diagonal. Okay, so how? Because it will be root 2s, right? If this is the value of s, that is the side of the right what square. Okay, so basically if we draw a diagonal in the square, what we are left with is two right angle isosceles right angle triangle, because this side and this side have same length and this is of 90 degree value. Okay, so since this is the formula, so given x for a right isosceles triangle, we can actually evaluate the diagonal. Okay, that will be root 2 x. So let's see the type of triangles by sides and angles. Okay, so isosceles acute triangle. Okay, where two sides have equal length, but all the interior angles are of this is less than 90 degree, this is less than 90 degree, this is less than 90 degree. Okay, so this is gamma, this is beta, and this is alpha. So all the three angles are of measure less than 90 degree. Okay, that is called isosceles acute triangle. Okay, so isosceles obtuse triangle. Okay, so an isosceles triangle with one obtuse angle and two equal legs. Okay, so where let this be alpha, beta, and gamma. Okay, so alpha is actually greater than 90 degree, but these two are can be randomly picked. Okay, but they must be both less than 90 degree. Okay, so this is called an isosceles obtuse angle triangle. Okay, so two sides must be have same length. So since these two sides have same length, so these two angles will also be same. Okay, so this is an example where one angle is 120 degree, the angle that is actually greater than 90 degree. So the other two can be evaluated using the formula, that is 2x plus gamma alpha, that will be actually equal to 180 degree. Okay, so this implies that 2x is equal to 180 minus alpha. Okay, so this implies that x is equal to 180 minus alpha by 2. Okay, where alpha is the what? Obtuse angle. So this is the obtuse angle. Okay, so let's see the seventh point, that is centroid. Okay, so the point of intersection of the medians, it divides each median in 2:1 ratio. Okay, so what is median? Okay, so these are all medians, right? So what happens is centroid is the point where all the medians intersect. Okay, as you can see right here, all the medians intersect right here. What is median? That is, it is the line joining the opposite vertex with the midpoint of the opposite side. Okay, so if we draw three medians, they will actually intersect at a point, and that point is actually called median. Okay, so in what ratio does it divide them? So it divides them in 2:1 ratio. Okay, two part is actually available in the angle side, that is this side. So this will be two part and this will be the one part. This will be the two part, this will be the one part. This will be the two part, this will be the one part. Okay, so cumulatively there will be three parts. Okay, so let's see what is orthocenter. So the point of intersection of altitudes. Okay, what is altitudes? Altitude is a straight line that is drawn from an angle or a vertex to the, and that is actually perpendicular to the opposite side. So this is perpendicular to this side, and this is perpendicular to this side, this is perpendicular to this side. So these are all altitudes. Okay, so basically they meet at some point, they intersect at some point. Actually all the three intersect at one point, and that point is called the orthocenter, okay, of the triangle. Okay, where the point that is actually the point of intersection of all the altitudes, that is three altitudes. Okay, so let's try to see what is actually in center. Okay, so the in center of a triangle is the intersection point of all three interior angle bisectors. So you know what is an angle bisector. Okay, so let's denote the triangle by ABC, and let this angle be alpha, this be beta, and this be gamma. Okay, so this is this angle, right? So what is angle bisector? A line that actually bisects that angle. Okay, so basically this angle is beta by 2, and this angle is beta by, this angle is gamma by 2, this angle is gamma by 2, this angle is alpha by 2, this angle is alpha by 2. Okay, so basically as you can see right here, so the point at which they actually intersect is called the incenter. Okay, so all the three angle bisector actually intersect at one point. Okay, and that point is called the incenter of the triangle. Okay, so let's learn what is incircle. So the largest circle that fits inside the triangle, touching all the three sides. Okay, so basically we have a triangle. So what we want is, we want a circle that is actually maximized. Okay, the maximum radius circle that can be drawn inside the triangle. Okay, touching all the three sides. Okay, that is called a incircle. Okay, and as you can see here, the incenter will be where? In the middle of that circle. Okay, so the largest circle that fits inside the triangle touching all three sides. Okay, so let's try to see some special points and lines in a triangle. Okay, so what is circumcenter? Okay, circumcenter of a triangle is defined as the point where the perpendicular bisectors of the sides of the particular triangle intersect. Okay, as you can see here, if we draw three perpendicular bisectors, okay, perpendicular bisectors, then what happens is, that is, we pick the midpoint and we draw a perpendicular. We pick the midpoint and we draw a perpendicular. We pick the midpoint and draw a perpendicular. Then all those three actually intersect at one point. Okay, that point is called the circumcenter. So let's see what circumcircle is. Okay, so the circle passing through all three vertices of the triangle. Okay, so here we have a circle and there is a triangle, right? So the center of that circle, okay, and the circle actually touches all the three vertices of that triangle. Okay, so what happens is, the center of that circle is called the circumcenter. Okay, the radius of that circle is called circumradius, and the center is called circumcenter, and the circle is called circumcircle. Okay, so let's go forward and see what similarity and congruence means. Okay, so what are similar triangles? Okay, so triangles with the same shape but possibly different size. Okay, so what do we mean by this? Okay, so basically, if you have a triangle, so since you can have different size, okay, size imply what? Length, right? Length of the sides. So the length of the sides can be different, but the angles must be same. Okay, so if this angle is equal to this angle, this angle is equal to this angle, this angle is equal to this angle, then we say that ABC is actually equivalent to PQI. Okay, so the corresponding angles are equal and corresponding sides are proportional. Okay, so if this is alpha and this is beta, and let it be ABC actually. If A is to B is actually equal to A1, this will be B1 and C1. A1 is to B1 and B is to C is equal to B1 is to C1, and A is to C is equal to A1 is to C. Then we say that what this triangle are equivalent triangle or similar triangle. Okay, this is what we mean by similarity. So what are congruent triangles? So triangles with the same shape and size, all corresponding angles and sides are equal. Okay, congruent angles mean equal angles. Okay, they are ditto same. Okay, their length can't be also different. Okay, so basically, two congruent triangles are actually similar triangles, but two similar can't be congruent. Why? Because in case of similarity, what we can allow is, we can allow different sizes, but in congruent triangles we can't allow different sizes. So basically, congruency is a particular kind of similarity, you can say. Okay, so let's see what is Pythagorean theorem. Okay, so in a right angle triangle, the square of the length of the hypotenuse. Okay, here you have a hypotenuse, this is a right angle triangle, this is altitude, okay, or perpendicular we can say, and this is the base, right? And let it be denoted by h, this will be p, and this will be p. So basically, h square is equal to p square plus b square, or we say h is equal to square root of p square plus b square. This is what Pythagoras theorem tells us, that is, the length of hypotenuse is actually equal to the sum of squares of the square of the length of the hypotenuse is actually equal to the sum of squares of the lengths of the other two, that is the square of perpendicular plus the square of base. So triangle area formulas. Okay, so triangle using base and height. So area is equal to what? 1 by 2 into base into height. Okay, so that is the formula for area of a triangle. Okay, if you are given the base and height, so let's say you have a triangle where base is 2 meter and height is 3 meter, so its area will be equal to 1 by 2 into 2 into 3, so it will be equal to 3 meter square. Okay, so what is Heron's formula? Heron's formula is equal to, area is equal to S into S minus A into S minus B into S minus C, where S is the semi-perimeter and A, B, C are the side of length. So semi-perimeter is what? So we basically sum up we take the perimeter and we divide it by 2. This is what called semi-perimeter. Okay, so using the semi-perimeter, okay, we can actually evaluate area. How? Using the Heron's formula, that is, area is equal to S into S minus A, square root of S into S minus A into S minus B into S minus C. Okay, so this is where S is the semi-perimeter and A, B, C are the side lengths. Okay. So angle bisector theorem. In a triangle, the angle bisector divides the opposite side into segments that are proportional to the adjacent sides. Okay. So here we have what? P, Q, R. Okay. Here we have A, here we have B. Okay. And here, as you can see, we have C. Okay. So let what? So angle bisector theorem. Okay. So this is the angle bisector of P angle. Okay. Of vertex P. So what it tells us, the angle bisector divides the opposite side into segments that are actually proportional to the adjacent side. So basically A is to B is actually equal to X is to Y. Okay. The angle bisector divides the opposite side into that proportion. Okay. So let's see what law of sines is. So for any triangle, sine A by A is equal to sine B by B is equal to sine C by C. Okay. Whatever the angle is here, basically it will follow this property. Okay. So you all know what trigonometric functions are, what sine function is. So putting sine function into the, so putting a value into the sine function and dividing it by its opposite side length, and doing the same with the others, and then what we can see is all the three are same. So this equality will hold. Okay, this is called the law of sines. So let's see what the law of cosines is. So basically, if you are given a triangle and you have the side length as A, B and C. Okay, so A square is equal to B square plus C square minus 2 into BC into cos A. B square is equal to A square plus C square minus 2 into AC into cos B. C square is equal to A square plus B square minus 2 into AB into cos C. Okay. So formulas used for triangle. What is perimeter? So the sum of lengths of all the sides of triangle. P is equal to A plus B plus C, where A, B, C are lengths of triangle's sides. Okay. So what is semi-perimeters? So half of the perimeter of the triangle S is equal to A plus B plus C by 2. Okay. Perimeter is nothing but sum of all the sides. So semi-perimeter is nothing but perimeter by 2. Or we add all the sides and then divide it by 2. That is called the semi-perimeter of a triangle. So Heron's formula we already know. A is equal to S into S minus A into S minus B into S minus C. So area is equal to what? 1 by 2 into base into height. This formula we also have already learned. Okay. So what is area of equilateral triangle A? So the area of the equilateral triangle using its side length. Okay. Formula A is equal to side square into root 3 whole by 4. Okay. So A will be equal to what? A square into root 3 by 4. Okay. So this will be the what? Triangle. Okay. So area of the equilateral triangle, if the triangle is actually equilateral triangle, then area will be equal to A square into root 3 by 4. This is the formula. So if A is given to us, A is equal to let's say 1, then area will be equal to what? 1 into, so it will be root 3 by 4 meter square. So if this is meter, so root 3 by 4 meter square. Okay. So that is how we can actually evaluate the area of equilateral triangle if we are actually given side length of that equilateral triangle. Okay. So let's see. Okay. What is a circle? Okay. You already know what is a circle is, and you know what a radius of circle is. So this is the radius, and this black demarcated length is called the circumference. Okay. And this blue line is called the diameter of the circle, and O, that is this point, is actually called the center of the circle. So diameter will be what? 2 into R. Okay. So the distance across the circle passing through the center. Okay. Where S is the radius of the circle, R is the radius of the circle. So area is equal to what? Pi R square. Okay. Given the radius of the circle, what you can evaluate is, you can evaluate the area of that circle, that is pi R square. So you can also evaluate what is circumference, and how you can actually evaluate the circumference of the circle. So it is actually 2 pi R, or actually 2R is equal to what? D, right? 2R is equal to D. So we can also tell that C is equal to nothing but pi D, or 2 pi R. Okay. So let's try to see what arc length is. So arc length is nothing but this part of the circle. Okay. Arc length is equal to 2 pi R into theta by 360. So theta is the angle that actually it makes with the base radius. Okay. So the length of the part of the circle boundary is called R. So S is equal to what? Theta by 360 into 2 pi R. So where theta is the central angle in degrees. Okay. So if we are given the radius and S, that is the arc length, then we can actually evaluate the angle it makes with the base angle. Okay. So R is the radius of the circle. So central angle. So the angle formed at the center of the circle by the radius, that is equal to what? S into 360 by 2 pi r, where S is the arc length, okay, and r is the radius of the circle, as you can see right here. So let's see what sector area is. So area of a sector in degrees. Okay, so r, and this is theta degree. R, then this is theta, and A is equal to theta by 360 into pi r square. Okay, so A is equal to theta by 2 into r square. So the area enclosed by portion of the circle's boundary, that is sector. Okay, so formula A is equal to what? Theta by 360 into pi r square, where theta is the central angle in degrees and r is the radius of the circle. Okay, so the area enclosed by a portion of the circle's boundary is called sector, and formula is what? A is equal to theta by 360 into pi r square. Okay, where theta is the central angle in degrees and r is the radius of that circle. So let's see what is tangent length. Okay, so radius of the tangent theorem, radius tangent theorem. So the angle between a tangent and radius is what? 90 degree. This is always 90 degree. And what is two tangent theorem? Two tangent theorem is if we draw two tangent at two distinct points in a circle, then they meet at the same point equal in length. So this length and this length will actually be always same. Okay, so basically if you draw two tangents from here and here, okay, one tangent will go right here and one tangent will come from here, something like this. So this value and this value will actually be same. Okay, this is what it tells us. So let's try to see what tangent length is. Okay, so the length of the line segment from a point outside the circle that actually touches the circle at one point is called tangent. Okay, so formula is what? T is equal to square root of r square plus d square. So where r is the radius of the circle and d is the distance from the circle center to the external point. So chord length C, okay, the distance between 2 points on the circle's boundary. So formula C is equal to 2 pi 2r sine C by 2. Okay, you are given C. Okay, so how you can evaluate C by 2? So you divide it by 2. Okay, so where r is the radius of the circle and C is the central angle in radians. So this capital C is called what? This is the central angle in radians, and C is the what? Chord length. So let's try to see what is chord and arc. So an arc is a curved segment of a circle. Okay, a chord is a line segment joining 2 points on the circle. So here you can see if you complete this, you will get a circle. So this part is called an arc. Okay, and a point connecting those two what endpoints of that arc is called chord. Okay, so chord is nothing but a line segment that actually joins 2 points in a circle, and arc is a curved segment of the circle. Okay, so I feel that's enough for today, and by this we have actually completed all the theory parts of this topic, area, perimeter of basic geometric figures. So in the upcoming lectures, what we'll do is we'll cover some exercise problems. Then after that, following that, we'll actually do some previous year questions so that you could boost up all your confidence. Okay, so thank you.